How do we explore before we build? Every prototype costs time. Every experiment reveals part of the answer. Digital twins make a different workflow. We can explore thousands of possibilities in a virtual environment before building a physical system. In this course, we will see how this became possible, from multi-physics modeling through data-driven learning to digital twins. I'm Wendy Guo from Uppsala University. Let's begin. What is a digital twin? We already interact with this concept more often than we realize. Think about a smartwatch. It continuously measures your heart rate, your activity, and your sleep. Those data are combined with computational models. As new data arrives, the model updates. It gradually becomes a better representation of you. Because the model evolves, it can estimate your current condition, predict what may happen next, and support better decisions. This is the core idea of a digital twin. A digital twin is a living virtual representation that evolves from its physical counterpart throughout its life cycle. How do you diagnose a failing system 200,000 miles away? Apollo 13 faced that challenge in 1970. Engineers recreated the spacecraft on Earth using telemetry data and models. Candidate solutions were tested before any decision was sent back to the mission. The term digital twin did not exist. The underlying idea already did. Digital twins first emerged in aerospace. They later expanded into manufacturing and many other domains. Most digital twins are built around the same learning process. It begins with observations from the physical world. Those observations update a virtual model. The model becomes a space for simulation, prediction, and exploration. New observations refine the model. Better models support better decisions. The process continues throughout the whole life cycle. A digital twin is valuable because it changes how we learn. During design, we explore virtually before building physically. During operation, the system keeps learning from new measurements. Across the entire life cycle, knowledge continues to accumulate. Different applications, the same principle. Learn virtually before acting physically. But none of this happens without a model. The model is where data becomes understanding. It's also where prediction begins. So next, let's look at how we build one.